Okay, now that we have a working power supply, it's now time to begin increasing the input voltages so that this will be closer to where the actual operating condition will be. So I've got two 6-volt storage batteries in series, which is 12 volts. And there's no charger on it now, so the voltage will be lower through these wires. Right now I'm measuring 12.5 volts, no load, primary input. And I've got a 2,500 ohm resistive load on the 550 volt high voltage output. This will sort of simulate the 12DQ6B final amplifier tubes in the Hallicrafters SR150. So let's see what happens. Okay, so primary voltage is only 11.6 and we're getting 502 volts DC out. The problem is we really need 13.5, 14 volts input to really be proper. So if we had that, this will be well up, 550, 560, maybe 575 volts. So yeah, the power supply is working. Yeah, my primary voltage is falling, as you can see. So there you have it, the Hallicrafters power supply, DC to DC converter, the PS-150-12 mobile power supply for Hallicrafters SR150 transceiver, and it's functioning. And the current drain at this point is 10 amperes from the battery. Keep in mind we have no filament supply for the SR150 running, and we have the low voltage supply open circuited, and so it's just the high voltage that's on there. So it's sort of a first level stress test, and it's functioning and holding quite well. I'll just turn this off. And I'm just going to feel the transistors. Nothing. There's like, no, they're not even warm. And they're equal, whatever they are. Just room temperature, really, and they're equal. So they're balanced. It's not that one transistor is working and the other isn't. Same thing here. There's nothing there. Just very, very room temperature, basically. Maybe 1 degree above room temperature. And they're both exactly the same. So that's it. This power supply is in service. Excellent.